Welcome to the Earthworks podcast, where our team will share the jargon of carbon with many of the turf friends we've met over the past 35 years.
Hi, everybody. Kevin Hicks. I'm back with another podcast. It's been a couple of weeks, but I'm excited for this one. This one came about from a post a friend of mine made on Twitter, X, and it was regarding calibration and tine management, T-I-N-E management of his TDR 350s. Got me to thinking, and I reached out and was able to get a hold of, through a couple of phone calls and transfers, I was able to get a hold of Doug Kieffer, who's the product training specialist with Spectrum Technologies. Their tool, the TDR 350 now, is pretty much ubiquitous in the industry, and I wanted to get him on, and since he's kind of the expert in the field, wanted to talk about not only that tool and some of the whys and the what fors, but maybe dive into some of the other offerings, because it's not, their company doesn't just do moisture meters. They do a lot of really cool stuff. So Doug, thanks so much for getting on with me, and this should be a fun time to chat about technology in the industry.
You're welcome. Thanks for inviting us.
Yeah, so we always kind of start at the top and maybe get a little bit of background on you. You gave me some background, but let's go over it for the audience. You kind of came to Spectrum through a little bit less than conventional way, but so tell me about that.
So my undergraduate degree is in aerospace engineering from University of Illinois.
Okay.
But anyway, as things turned out, and I was still young and I didn't have any family, I didn't have any commitments, I got into my head that I wanted to do some sort of kind of volunteer work overseas. And so I looked into the Peace Corps. I'm a Roman Catholic, so I was looking at Catholic mission opportunities.
Okay.
And the latter is what I landed on. So I ended up working in a Catholic mission over in Uganda for 3 years. And I was teaching math and physics in the secondary school there, which is kind of like the high school.
Three years straight? You didn't come back at all? Okay.
No,
Very cool.
94 to 97.
Okay.
So it was an interesting time. Uganda had just come out of a civil war, like a 7-8 year civil war, a couple years before that. And I mean, a couple months after I got there, and this will place it on the calendar for you, was when O.J. Simpson did his thing.
His little tour.
And when the real horrific pogrom took place in Rwanda, which is, if you don't know, Rwanda is just south of Uganda. It's the southern border of Uganda. And so there was a lot going on in Uganda related to what was going on in Rwanda then.
Sure.
So, and I mean, that's a whole other story, not for this podcast. But anyway, so when I got back to the US in 1997, I don't know, I didn't really have a burning desire to try to integrate myself back into the aerospace industry. So I started looking at doing things like with agriculture. So went back to school, back at University of Illinois, and got a master's degree in agronomy, and things just came together. You know, Spectrum was a fairly new company back then, and but it did technology stuff, but it was with agriculture, and it was in the Chicago area where I grew up.
Perfect.
So it was really a perfect fit. And 25 years later, it's still
here we are
in a different room.
So your title being product training specialist, are you have to be involved with your background in product development too, right?
Kind of. So Spectrum is still a pretty small company, so you have to put something on your hashtag there, or whatever you call it, at the bottom.
Yeah.
But mostly now it's technical support.
Okay.
But because we do have a product development team, but a lot of that now is with electronics and telemetry.
Sure.
A lot of doing that kind of thing, getting sensors into the weather stations, getting them done. So, but sometimes we do some testing with, say, like the TDR meter, or some that we have a pH probe that, well, we resell, and we have to confirm that it's working or whatever. So you wear a few hats when you're at a company with only like 25, 30 people.
Yeah.
Right?
Yeah, I'm sure.
I mean, I'm not an accountant. I don't do any account stuff, and I don't do any sales stuff, but other than that,
sounds like the perfect world. You just
it is
just do what you enjoy.
You can do stuff like, oh, we need to promote this new product. Well, what are you going to do? Well, the marketing guy doesn't know the technical stuff so well. So sometimes the tech support people get in there to help. This is way, because and nothing against any engineers out there, but sometimes they're not the best for communicating how things work to the end user.
Right. And you can throw stones because you live in that glass house. You are an engineer,
right? Right. But most of the time we're talking to customers.
Sure.
And so yeah, you're sort of the liaison between the technical people and the sales people.
And I'm sure that having your agronomy degree as well is incredibly useful when you're talking to people, and you can actually talk the talk and not just engineer speak. So that's really cool. So I want to go back to, I know this isn't a podcast about mission work, but I'm always curious when people do international work like that. How did that change you? I'm always curious about this, and is it something that still sticks with you as far as that experience goes?
It absolutely does. And now you're getting into sort of this religious side of it, but I have to admit, I kind of went there sort of with a sense of adventure.
Sure.
Go to Africa or Latin America, not really. But as I said, they had just come out of a real bad civil war, and you saw a lot of remnants of that all over. Because I was out in sort of the rural area in a village. And it was really awe-inspiring to see, how strong the faith was of the people where I was living, the students, their families.
Right.
Because we were, kind of the white people there, it was kind of a novelty. So they would invite you to their houses, one day, for a whole day of visiting and stuff. And so I came back, I would say, more evangelized than anybody that I spoke to over there.
Cool.
And I'm still really not in touch physically, but like anything about Uganda, especially, it piques my interest. But things in East Africa and stuff, I pay maybe closer attention than maybe most people would, just because I lived there.
Yeah. Have you been back at all?
Once back but it was like in 2008. So, and my family, we went there. Our kids were really little then, so I don't think they remember that time. But it was, and even then, that had been about 10 years, and the change had to take, because now, so when I left, there was no really such thing as an internet,
Sure.
And then I come back, and all this stuff had just it was like a Rip Van Winkle thing. You went away, and then you come back, and all this stuff is happening. And so then, 10 years later, going back to the village where I was, so if you wanted to make a phone call to the U.S., you had to go to the capital city, and it was a big project.
Wow.
But even as of 2008, the Chinese had gone in there and they built a lot of cell towers. So now all these people have cell phones; they can connect. They're like connected to the world now. And so again, that's got to be something for them, that they're kind of, you're just stuck in your little thing, and now you can be talking to Sweden,
amazing
easily. When I was there, you were it was a lot more isolated. We had to get to the capital. We had to mail was a month to get something to you, kind of a thing.
A true immersion program, right? You're in it, and you have no choice than to be in it.
And I've heard people in the military have a similar experience.
Yeah. And
it's tough, right? You're in Afghanistan or Iraq, it used to be you just did your thing, but now you could be talking to your 2-year-old, and now you got to go. And I'm saying, I don't know. I think it's good that you can be in touch, but there's also the downside that the being in touch all the time, and then you walk out your door and like, wow, I'm in a different world.
World, yeah. I've got a cousin whose husband is a doctor, and they started a clinic in Tanzania, and they're over there 2-3 times a year, and we haven't dove into that a whole lot, but it sounds like it's just been fascinating for them, and the kids have kind of grown up with that piece in their life, and which is kind of cool. They're Midwesterners, but they get a completely different cultural experience a few times a year.
I've seen those kids when we were there. There was a hospital nearby, and they had young children there, and had been there for several years, and then went back to England or whatever. Most of the people in East Africa are coming from Europe, not as much from the United States. Yeah, so that's more like Latin America stuff, just because of time zones or whatever, or however it worked out. But and I was always like, man, these kids are going to go back to wherever their family is from at some point, and had a different childhood than
no kidding.
People they're going to meet, going roundabout.
I think that's okay. All right. Well, that was an aside, but I'm always fascinated by that. So tell me about Spectrum. How did Spectrum come about? What fields do they serve?
Hmm.
Obviously agriculture is centered
Hmm.
to what they do, but what
Hmm.
what all does your company do?
So the origin story is kind of interesting, and if if you want to have another 2-hour podcast, get our owner, the guy, the president of the company.
Yeah.
So he was he grew up on a farm, and he went to he got a master's degree, what do you call it, a MBA.
Okay.
And I guess part of this of your MBA program is that you have to write up like a business plan, right? So if you started a company, what would your business plan,
Right.
And that's
Right.
like a project for a student to
Yep.
do. I don't know how many of those things come to fruition, but his did. His business
No
plan was what
kidding.
ended up being Spectrum Technologies. So this was back in the probably early mid 80s. And if he listens to this podcast and I say something wrong, I'm doing it in good faith. But so he got out, and having so after before he did the MBA, he was working, or maybe so at the same time he was working for, I want to say, Case IH
Okay.
with equipment sales.
Sure.
So
Yep.
he grew up on a farm, and then he was, this heavy equipment, reapers and all this kind of stuff. So he knew the kind of the engineering side of it as well. And then, you know, so something that he kind of realized was, at the time, and I didn't grow up on a farm, but it was like, well, if a little input is good, more is better, right?
Yeah.
A little nitrogen gets you this much corn, even more nitrogen will give you more corn, and da 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 da. But he kind of could see that the days of that were couldn't last forever, right? It
Right.
costs money to put all that stuff on.
Diminishing
There's gonna be
returns.
diminishing returns, environmental concerns, right?
Yep.
The nitrogen getting into the Mississippi River and getting
Sure.
down to the Gulf and the hypoxic areas, and restrictions on watering and all these kinds of things were going to come. So he said, if we can help people measure those inputs, they're going to be able to manage them better.
Excellent.
So he was, just on his own at the time. And so I know one of the first things he did is he got a pH meter. And I don't know what this pH meter was used for. It may have been something for like the medical industry,
Mm-hmm.
but he made a soil pH kit, So he had some cups and some measuring things and a reagent to put into the soil, da, 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 da. And then, it was just a lot of, rubber on the road, going to trade shows, calling
Sure.
people, hey, I got a soil pH kit. You don't have to send your stuff to the lab. You can get it right away. And he identified a lot of these kinds of things because at the time, and initially, it was just reselling products, but repurposing them for the agriculture industry. Davis Instruments made these weather stations for like
Yep.
weather hobbyists
Yep.
that I bet growers could get benefit of knowing the temperature and humidity and rainfall.
Absolutely.
And so we started selling those. So that was not even the market they had considered, right? So he was opening up something for them. And then people were like, who had weather station? It was like researchers, right? These $2,000, $3,000, $4,000 stuff
Right.
that they're doing but a grower could get a real affordable weather station. And you have a guy that grew up on a farm that kind of helping him walk him through that, right? So that was how it kind of started. And
Interesting.
then got
Wow.
another employee to kind of help with orders as the business grew. And then he couldn't really take care of all the shipping. So then, a shipping guy came in. So when I started in 2000, he was answering the phone, doing troubleshooting calls, back in the back, packing stuff up.
No kidding.
you
Wow.
hear
I had
about-
no idea that
You hear
that's
about that.
backstory.
And then as the company grew, then we got a dedicated salesperson for the turf industry.
Yeah.
Because you're saying, agriculture in general, and people ask me, what do you do? I do, work for this company, sort of ostensibly in the ag industry, but really it's anybody that grows stuff.
Sure.
So we have a lot of golf course superintendents because they're growing grass.
Yep.
And there are challenges involved, and they can't just look at it and know, right? They have to get in there and get some measurements. Greenhouses and nurseries and those kinds of things. So it's not just, corn and soybean growers.
Yeah.
Right.
Yeah.
And then that he really has a gift for identifying you know, things that are being used for other things, and we can use them. And then in the last 10, 15 years at least, have brought in like a development arm ourselves for things like the TDR
Yeah.
meter and other things that we build ourselves.
I want to get into that whole what's on the horizon talk, but I want to start with, I ask a lot of my podcast guests what and generally speaking, they're professional turf managers, whether it's lawn care or golf course management or sports turf, what their top innovations are in the industry, whether they've been in the industry for 10 or 30 years.
Mm-hmm.
And for me, the original TDR, the 300 and now the 350, and you've got a competitor or two in the market as well. And I think that is in my top two, as far as really a paradigm shift for not only how we manage our turf, but for me, it was a tremendous training tool to equate my feel to a number, right? So that assistants or irrigators, I knew the feel. I thought I knew, but I felt like I knew, but it was always hard for me to convey what that was to somebody. But now all of a sudden, a 20 or a 10 is a number that they can equate really easily. So, explain what TDR means, because I think that, I know the acronym, what it stands for, but and what and how it's measuring.
So, right. So the acronym stands for time domain reflectometry. And just saying that time domain thing, it gives you a hint that this is some sort of electromagnetic wave theory thing. It's a transformation, mathematical, blah, 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 right? But what it really comes down to is you're sending an electromagnetic wave, like a radio wave, down a waveguide, and it travels along that waveguide, and the speed that it travels is dependent on something called the dielectric permittivity. Okay. And now there are several things that affect the dielectric permittivity. Soil moisture, though, is by far the most impactful.
Right.
But organic matter content, soil texture, salt, that also has an effect, and some more important than others. In fact, where the technology originated was is in I don't know, people that are putting down cable lines, okay, or they have to repair cable lines. So there's a break in the cable, and it's an underground cable, right?
Yeah,
so you
mentioned this, and I never would have made this connection. So yeah,
right.
Go into this a little bit.
So what they did is, the cable, this thick cable, has a known dielectric permittivity.
Okay.
So they would launch this wave down the cable. It would hit that discontinuity, that break in the cable, and it would reflect back. And then they were able to find, how far that cable break was. Now they know where to dig, right? And so it is sort of an aha moment. I don't know. It was a man. His name was Clark Top. He was up at the University of Guelph, and this was in the early 80s.
Okay.
And I don't know how he thought of this, but his idea is, what if we do the opposite of that? Is that we have a known length, the tines of a waveguide, but we don't know what the permittivity is, because the permittivity is governed by the moisture in the soil.
Right.
And they hooked it up to the same thing. It was a cable. That's what it was called, a cable tester. And they started doing experiments with different water contents and all this kind of thing in different soils. And they found that the volumetric water content correlated excellently with what they call the apparent length that was coming out of the cable tester. So that was how it started. And these were always, so they're doing the opposite of what the cable testing people do. Another use for TDR actually is, and this is, I don't know how common, but it's for predicting avalanches. So what they do is they have a wire buried under the ground or under the snow or something. And if the ground or the snow starts to move, it kinks that cable, and they tell them that there's movement of the rock or the snow. So it's the same thing. There's some sort of discontinuity in that wire. So that's another thing they use it
S-
for. So yeah,
Similar
and
technology, but you don't manufacture that
no,
type
that's
of instrumentation. Okay.
no. And so
Okay.
these were, sensors that were buried in the ground, and yeah, and then we just found that instead of burying them in the ground and connecting them to some permanent, some data, like weather station,
Yeah.
yeah, you could put it on a portable device and
Right.
measure it that way. So that's what it does. And so yeah, for the TDR 300, I mean, we always knew about the salt thing, but there wasn't really much we could do about it, or that we didn't. But we did have two textures. We had high clay and a standard soil.
Right.
So people could at least get a little bit closer. But in the end, it's kind of like you said, you just need to find your magic number, right?
Yeah. Yeah.
Now these things are so ubiquitous, but at first, it was a really pretty new thing. And so somebody, well, I'm interested in this. And the thing we would say, and I would even say this today to someone that's never used it, well, you're doing something else now. You're putting your knife in the ground and pulling out this thing and squeezing it between your thumb, right? So go take readings with the meter, do it, whatever you're doing now, and then say, well, based on what I'm feeling with the soil in my thumb and index finger, I say
Yes.
it's time to irrigate. The meter's saying 18%, right?
Yep.
So, and
That's
then,
that's exactly how I learned, and it was incredibly difficult to convey that to somebody
mhm,
who I was trying to educate on that. And
mhm,
I likened it to when you'd watch your grandmother check the cake with the toothpick, and
mhm.
does the batter come off, or
Yeah.
is the toothpick clean? And that
Hmm.
resistance on the pocket knife told me there was moisture. I didn't know what the number was, but it told me there was moisture, and uh, incredibly difficult to teach that to somebody. But boy, when you could convey it in a numeric form, that's why I think it's such a revolutionary thing. So you talked a little bit about tine length, and I
Uh-huh.
know you offer several lengths. Why is that important?
So because what the meter is really responding to is how long it takes that wave to go down and back.
Okay.
Um, so you're getting an average water content from the surface down to the tips of the rods.
And down and back, you mean only traveling the length of the tine, not into the
Uh-huh.
ground.
Not into the ground, right?
Okay.
So from
Okay.
the base of the sensor block down to the tips and back. So you get a number, and as far as and this is important when people are doing calibration, that the field of influence of the probe extends about an inch away from the rods. So if you imagine a cylinder about 3 or 4 inches wide,
Okay.
and then the height is the length of the rods, you're getting an average water content in that whole cylinder.
Okay.
And so if it's a little dry in the surface and wet lower down, or vice versa, it's dry and you haven't irrigated enough, let's say, and it's wet at the meter doesn't know that there's a difference. It just gives you the average.
Sure.
So you just have to be aware of that. So for turf, 3 inches is the most common rod length, followed by 4.8 inches. Because
And
that I
then
think is the
and does that cylinder that's trying to picture this or trying to explain this and verbally that cylinder is horizontal, correct? So the two tines on the meter somewhat overlap. Is that the way
no, all
I'm
right.
envisioning it?
So imagine like a point right in the middle of the two tines and
Yeah.
take the tines away. That's the center of the circle of the cylinder.
Okay. Okay.
You see what I'm
Got it.
saying?
Got it.
And for calibration, one thing you have to be careful. And I know a lot of superintendents use the word cup, and when they say cup, I'm thinking solo cup. But I think for them, when they say cup, sometimes it's like where they mix their fertilizer or something.
Sure.
But anyway, knowing that that's the field of influence of the sensor. If you have a cup that's really narrow, the rods can fit in, but part of that, imaginary cylinder is outside of the cup.
Yes.
You're doing a calibration partially in air, so you don't want to do that. You want to have like a bucket, so to speak, so you can get the rods all the way in, and there's plenty of water around the rods as
Okay.
well.
And that's what sparked this whole conversation was a post by a friend of mine that on X that got a lot of attention, and it was about calibration, and realized that he was running I think 3 or 4 units, and it wasn't so much that he felt like he'd fallen off on calibration. It was that the units didn't seem to match up.
Hmm.
and so he didn't feel like he was getting good clean data, and he started down that road, and it sparked a ton of conversations. So I thought it'd be great to talk about it. So from your company's perspective, is there and I think you kind of dispelled this a little bit with me on the phone, but is there a recommended calibration period, recalibration? Is there any calibration required? Just kind of clean that up for me a little bit.
So the calibration really isn't required. In fact, now with the 350s, when you start the calibration, it says, hey, it's factory calibrated. You don't have to.
Okay.
The very first TDR 300s, that option wasn't there. But then it became a sort of a victim of its own success. People went from having one TDR 300 to having three or four.
Sure, sure.
Oh, and then this one's reading 2 or 3% different than this other one, you know? And so the idea behind the calibration initially was to sort of sync up multiple meters so that they'd be interchangeable.
Okay.
So if you calibrate all your meters at the same time in the same liquid, they should then be matching up, and you could.
And if they're not, is there something we can do in the field to correct that, or is that more we have to send them into you?
Yeah, if it's not able to calibrate, or the calibration is still not coming into where it's supposed to, that's indicating a failure of the sensor block, so it needs to be replaced. Yeah.
Could it be, and this is another thing you kind of cleared up for me, but I wanted to get this out. Could it be wear on the tines? And you kind of indicated that there could be a fairly that the tines don't tend to wear very much compared to what we maybe expect, and that there could be a fairly big wear pattern without affecting the readings. Is that correct, or did I misunderstand that?
So it is remarkable how much they wear in a sand-based putting reed.
Of course.
I mean, we've gotten them back sometimes, and they're really worn down. Now, these are like thousands of readings, obviously, because it's every little scrape takes a little bit out, you know.
Sure.
But remember, what it's really measuring is how long it takes the wave to go down and back. So if you have 4.8-inch rods and you take a reading, it assumes that wave traveled 9.6 inches, right?
Right.
But if those things are worn down to, say, 4.5 inches, now that wave has only gone 9 inches, it thinks that the wave went faster, right? It doesn't know the speed. It just knows it went this amount of time, so it must have gone faster, right?
Which would then increase or decrease the moisture percentage?
I know. I think that means it would increase. It thinks there's more water there.
Okay, that would make sense.
But all right, so if it wears down a little, I mean, you know, obviously you don't take one reading and change the rods.
Right.
And theoretically, if they wear down a little, doing the calibration will kind of bring it back in again. But you don't want to count on that forever. You know, at some point, you know, you're doing a pretty big adjustment to get it to read properly. We've gotten some data, but nothing really definitive, like when it gets down to this mark, replace them. But I think I mentioned in a note to you, sometimes when people send back the meters for service, the rods come with them. They don't, you know, they send the rods also. And that's what we see in these really worn down rods.
Yeah.
Never seen them more than like 5% worn down. So I think just the group think is that once it gets down about that small, and they also look, because they don't just get shorter, they get thinner too. They get worn down into these kind of thin pointed things. And so
very, very sharp.
And sharp. And so you look at it, if you happen to have new ones and you see those other ones, wow, this looks a lot different. And so they just buy replacements. And so
they're not expensive. I think we did them maybe annually or something, just to try to keep them all fresh. And so when you do change out of time, there's no need then to do any calibration. It's kind of a reset.
Yeah, it's especially if they were really worn and you just calibrated them when they were really worn, maybe put them back to when they, you know, for a new rod. Yeah.
One of the things that this will probably make you cringe. One of the things I always note when I'm visiting with a superintendent is the storage of their units, and you know how they keep them in their car. And I'm telling you, Doug, it is soup to nuts. Some guys have the fancy gun racks on the roof of their carts. Some guys have one of my assistants. Hopefully he's listening so that he knows he's in the wrong. he had tines down on the floor of his cart, just bouncing around the golf course.
Oh,
And I mean, that's pretty obvious, and he knew he
mhm.
was wrong. But do you have any recommendations for that? I mean, do you have any kits that I know you've got a zip up bag, but do you have
Right.
anything that's rather inconvenient, I guess, if you're
Yeah.
using it all on a daily basis?
Yeah. Right. That's more for like transporting it, like you're traveling somewhere and you
Yeah,
would have it in there so it doesn't bounce around. And I guess it's just more just, I don't say common sense, but yeah, you don't want it bouncing around because you got like batteries and wires and
right,
stuff in there. So that's
right.
knocking against stuff. Um, I mean, it's water resistant, so if it gets sprinkled on, that's one thing. But obviously, the display, you don't want it to be soaked.
Sure.
And sometimes they do. I mean, it's not hermetically sealed, so water. So if it's too wet for too long, that can get in there. And the only other thing, and I think this is just a general thing with electronic stuff. So over the winter, I think most people take the batteries out. It's not required, but they're not helping you being in there.
Maybe if you're in a
Um,
seasonal climate or something like that, take them out in
yeah,
the
they'll
wintertime.
take them out and then put the batteries
Yeah.
back in.
Okay, one more question related to this, and then I wanted to kind of move on to some other stuff. But I think I think I'm remembering this correctly that on the tine themselves, and I'm doing a lot of hand gestures for those those of you that are listening on audio only. Um, at the end of the tine, there's a flange with a basically a wrench fitting on it, so that you
Mm-hmm.
can tighten that down.
Mm-hmm.
My understanding, and do correct me if I'm wrong on this, but my understanding is that that's a pretty critical thing to be in contact with the soil. Is that how I remember that instruction? Or can you
Well,
do, in other words, if you've got a 3-inch tine,
mhm.
can you get an accurate reading if you only drive the probe in an inch and a half?
No,
Okay,
no, because again, because it's measuring the travel time of the wave. So if it's traveling partially in the air and partially in
it's
the
still counting
wet,
it.
it's it's gonna says now that might go a little slower because it's in the air, then it travels when it's in the wet soil, but it's going to take the average of that whole length. So you do need to put the whole thing,
Okay.
push it all the way up to the pro block.
So if you've got a Poa green and you've got I can't remember how short the shortest tines are. Are they inch and a half, maybe something
Hmm.
like that?
Hmm.
So you want to match the tine to the depth of your
Hmm.
desired sampling.
Hmm.
Okay.
Hmm.
Okay.
Now
Yeah,
there is an option, although you know it adds a little bit of noise, but there's a spacer block you can get with the 1.5 inch rods, so that only a half inch or an inch of those rods goes in the ground.
hmm,
And we've done the special conversion equations for those because we know now it's either traveling all the way in the ground, but if the whole inch and a half rod is put in,
yeah.
or it's partially traveling in plastic and air. And so we've actually done the collected the data for that. So if you only wanted to
Huh.
go in a half an inch or an inch, there's that spacer block that you can get. And that was actually recommended in the original research that was done by a turf researcher down in North Carolina, NC State. And he said, "Look, I did this." He put like a little wood block on there, and he
Right.
and he showed us his stuff,
Don't do that.
and then he said, "Why don't you do that?" And so then we actually did it formally and created this spacer block.
So is that just a setting that you can change
Hmm.
in the machine? Okay.
Hmm.
I didn't
Right.
realize that was
It's
available.
an extra and it's an additional rod length option
Okay.
for half inch or 1 inch, but you have to have that spacer block. You can't just push it partially in
Yeah.
because
Got
it's
it.
assuming now it's going through that plastic and you know.
Okay. So TDR 350 then added conductivity.
Hmm.
Why, what was involved and why did you decide to
Hmm.
introduce that?
So there are, in addition to soil moisture, there are three other factors that can impact how that wave travels through the soil: the organic matter content, the texture, and the conductivity.
Okay.
So we kind of accounted for texture a little bit by having with the 300, we had two
Yep.
settings. With the 350, we added sand because the majority of people using it are using it like
Sure.
USGA sand.
Yep.
So we added that extra texture, and then we added a correction for conductivity. So there are two modes. There's the TDR 300 mode where it acts just like the 300.
Okay.
And theoretically, it would be the same as if you had a 300. And then there's one where it corrects for conductivity. Because people with the TDR 300s, if they were in like saline conditions, they just had to find their magic number, right?
Sure.
If they had maybe higher salt levels in their soil and they were getting a number like water content of 34%, chances are the water content wasn't actually 34%. It was something a little bit lower.
Okay.
But the salt was, but they just said, well, all right, I don't care. I really don't care what the water content is. I just need to know when to put water down or not.
Yeah.
So
yeah.
That was sort of the workaround for it.
The conductivity was always being taken into account. It just wasn't showing up on a screen, correct?
Well, it was always affecting the number.
Right. Okay.
It was always influencing what the number. So you would end up getting higher VWC numbers than what the actual VWC was. Volumetric water content, I'm saying an acronym, right?
Yeah.
But, so with the 350, if you have it in the VWC mode, where it compensates for EC, it should be giving you something closer to what the actual water content is.
Okay.
So you don't have to do that workaround. I just got to see what it reads in my soil.
Well, being in the Western U.S., conductivity and salts are always a concern, especially in the Southwest. So that added feature has been a pretty valuable tool, I think, for a lot of guys that use it on a regular basis. And everybody, it's a little bit like a stimp meter reading. Everybody's numbers volumetric water content numbers are very personal. You know, it's not something that we want to get into a contest with our neighbor on because the makeup of your soils are completely different. You know, I've got a neighbor over in the Spokane area that he said he would absolutely hit the panic button with POA greens if his number ever dropped below 20. And, you know, I was constantly striving to get below 10. Well, he said, geez, my greens would be dead. And but the EC, I think, has been nice because guys can then set a threshold for things like flush cycles and you know, related to the salts in the soils. Okay, so that's awesome. That I think that answers all my TDR questions. I appreciate that.
So I'll just add one thing, and this is just a question that comes in sometimes. There's a temperature that gets read also.
Okay. Yeah, that's right.
And sometimes the assumption is that it's the soil temperature, and it's not. It's the surface temperature.
Okay.
And so they'll say, man, this is saying 80 degrees. There's no way my soil is, and it's not. It's a contact sensor on the bottom of the sensor block. So it's really getting, and in fact, if you really wanted surface temperature, there's an infrared temperature sensor option that you can get. And I think people use that for disease pressure. I don't know.
Yeah.
But anyway, some people think that that's beneath the soil temperature, and it's
I
not.
always did.
Well,
I'm glad you
go.
clarified that. No, that's good. That's good. Yeah, I guess you know, knowing a little bit about how that probe worked, I assume the same thing. So
there you go.
That's
So I'm
good
glad
you
I
clarified
mentioned
that.
then.
Okay, so we talked about the moisture sensors being ubiquitous, and I actually had some of the old in-ground units, you know, that would log things, and they were fairly rudimentary, but they were valuable for specific sites. And that's always been my question. And another reason I think the TDR, some of your competitors' tools became so valuable is that, you know, there's still a lot of in-ground sensor technology out there. But the question has always been for me, how many is enough? Versus having one in your cart that you can take specifically to all 18 greens and you know, do things that way. So what I wanted to kind of touch on as we get near the end is some of your other offerings and how they're being used, but also maybe what we're not thinking about that your company manufactures that might be of value to us.
So I wanted to, as you were saying that, I wanted to, it made me think of something. You're talking about being on your cart and so forth. And it's this idea of the irrigation audit.
Okay.
And this is another thing that the portable soil moisture probes can add to, or anything that can kind of map things.
Sure.
And this was a guy named Brent Meacham, and he used to work in Colorado. Now he's, I think, with the irrigation, so unless he's retired, I'm not sure. But
Okay.
so the traditional irrigation audit puts the catch cans out there.
Yep.
You run the sprinklers, and you find the unit distribution uniformity. And his idea was, what about measuring what's in the soil itself, right?
Sure.
And let's compare. Let's do, and I've done it myself. When we first came out with the TDR, we did this, and we were kind of out trying to really evangelize for that for a while. Like the irrigation, doing it with the moisture probe, it's a lot easier. It's a lot faster. You don't have to mess with the cups and the wind speed and all that. You just go. And the interesting thing is that the catch can audit is really good for evaluating your sprinkler system.
Right.
Is it putting water where you think it should be? Is there clogs or something broken?
Kind of a starting point, right?
So you want to say, is my sprinkler system doing what I want? The catch cans are perfect. But if you're talking about agronomy, right?
Yeah.
Because just because the water touches the grass doesn't mean it drills down into the soil.
Yeah.
It goes where it wants to go.
Right. Is it being received properly?
And we did a little study at Michigan State University, and it was interesting because we mapped it. We mapped the catch cans, and we mapped the TDR numbers. And if you were looking at the catch cans, there was a part of this green that we were studying. We said, "Man, this thing has got too much water. We better cut back on it or whatever." But the soil moisture data there was really low. And so, of course, this is the superintendent. Hey, what do you think is going on? He goes, "Well, what happens is the cart path. That's where people walk onto the green. So it's always really compacted."
Right.
So, in fact, we have to go there with the hand watering it all the time because it gets dry because the water doesn't, and we aerate, but whatever. So anyway, if all you had was the catch can audit, you would have maybe reduced water to that one spot that actually needed it more because it was a kind of a compacted area because it got a lot of foot traffic. And so, anyway, that's a thing that now is starting to get a little more traction.
Kind of a ground truthing sort of idea, right?
Let's audit. All right. So even if our sprinkler system is working perfectly, we might be having dry or wet spots,
right?
Because of what's going on underneath, compaction or whatever, or topography or whatever, in the sun and not in the sun, sort of thing. And so, we have our sprinkler system tuned perfectly, but we still know because of our soil moisture data, we got to go out and kind of hand water that little part a little bit more.
Right.
So this idea of the irrigation audit is another thing you can do with these portable probes if you're able to map soil moisture data.
Love it. And your mapping capabilities, I never utilized them, but your mapping capabilities are pretty robust, correct? I mean, as far as so tell me how we would use that.
So with the TDR 300, you had to get like an external GPS receiver from Garmin or something, and download it. So you come up with a new product. Why don't we just put GPS right in there? So it is, and there's a Bluetooth radio as well, so that you can send the data, via an app up to the cloud. Now the data's all there, and then there's a web utility that you can subscribe to that then allows you to do the mapping.
Okay.
And the data goes right from the meter right there. You don't have to have extra stuff that you hook up and that sort of thing.
Anything down the road as far as integration with the irrigation manufacturers to be able to do some real-time adjustments? I mean, that's always the holy grail. You've got so many great tools in this industry, whether it's stuff that Spectrum produces or GPS sprayers or whatever it is, but everybody's working in their own silos, and it would be, as a practitioner, it'd be great if we could pull all this stuff into one site and on the fly make changes to irrigation and fertility and the whole thing.
I don't know of anything that being used in turf, but in sort of pivot irrigation. And the owner, he's been in touch with somebody that does a lot of work in this, and went out with the longer rods, the 8-inch rods.
Okay.
And really intense. I don't know, he must have been there forever because he got a lot of data points on like a 40-acre field. And was because I guess with some of these pivot irrigation systems, you can sort of move it up and down you can program it. When you get to 40 degrees, put a little more water. Now, when you get down to 60 degrees, a
Based
little
on
less
ground
or
speed, I
whatever.
think, right?
Yeah.
Yeah.
Or maybe it goes faster. I don't know how they
I
do
think
it.
that's how it works. Yeah.
And so when they can find out where the dry and wet spots, they can program that pivot to put the water down better.
Sure.
But it wouldn't be a real-time thing. It's like when we mapped this, now let's reprogram our
Yeah.
thing. I think when I think of like real-time integration with irrigation would be the soil moisture sensors that are in the ground, or like rain sensors.
Right.
Because I think it's raining and the irrigation is on because we have the timer
Right.
set.
Yeah. Interesting. So, okay, so let's kind of talk a little bit about some of the other things. I mean, the EC meters, obviously you do a lot of work at the greenhouses, so some of that stuff is maybe more of a pocket style, or it's got a tether like some of your original moisture meters. pH meters, what other things should we be thinking about?
Right. So if you're thinking like greenhouse, right? So EC and pH really important. We also have some portable nutrient meters, nitrate being the most important.
Okay.
And they can do soil tests. They can also test the plant sap, right?
Okay.
So they, we also have some chlorophyll meters, which are really greenness meters. So they're getting either like NDVI, or the SPAD meter is something that's been around for a long time, where you can really quickly get assessments of the nitrogen needs in corn or wheat or something like that. And because like for corn, there's a time when it wants to uptake the nitrogen, right? And it's dependent on what where you are at, like the 6 leaf stage or something like that.
Right.
So if you have adequate nitrogen at that time, you're good to go. But if not, it tells you now and can give you an idea of the quantity. This deficient or that deficient. And of course, these things also be used for research, right?
Sure.
We're intentionally stressing the plant. We want to know the effect. And so for like those chlorophyll meters, the alternate is your eyes. That one looks a little yellower than this one, but maybe 1 to 10 you can grade it on, rather than something a little bit more precise and not dependent on whatever human factors. So people are colorblind to some level. The sun is out, the sun is not out. I just ate lunch, I'm unhappy, I'm grumpy because of something. You take all those things out and
just give you the numbers, right? Yeah. I remember when you first released that NDVI, and Bill Johnston at Washington State had it out to my facility, and I said, if you ever show my owner this, I will kill you with my bare hands, because I was completely judged on the color of the grass, not the quality or anything else. And I said, I will kill you myself if he sees this thing. But yeah, really valuable. And I know there's some drone technology being utilized with NDVI now. And it's just interesting to watch how our industry has gotten very technical. I was at the U.S. Amateur out in San Francisco a couple weeks ago, and I mean the data being collected. You mentioned the Clegg hammer, or the tool that you use to measure that, and that's another thing that I think is way more prevalent in sports turf, but that's another thing that you worked with the USGA on. Maybe talk real briefly about that one too.
So that's the firmness meter. It was actually developed by Matt Pringle at the USGA, but it was way over engineered. So it was like $3,000 or $4,000. So there was just a few USGA agronomists that had it.
Okay.
And so anyway, they reached out for us. Could this technology be used, made more affordable? And so we did a lot of things to simplify it, to get it into a price point where a superintendent could use it. And let's see, I talked myself into a corner here.
Clegg hammer.
But right to get the firmness, how much of a dimple does that ball make? And again, it depends on what their goal is. If this is like a high level, like a professional tournament, they want that thing to be like a tabletop.
Right.
They want it to punish people if they make a mistake.
Yeah.
But if you're a public course, maybe you want it to be a little softer, right? You want the people that, hey, it landed, hey, I stayed on the green, I'm happy, But how do you know? I mean, there was they were using those 1.5 inch rods, thinking, soil moisture, and it does. That's part of it, but there are other factors. So being able to just drop that weight on there,
Yeah.
They're able to get a better. And again, it doesn't matter who does it. You can give it to anybody. Tell me what the number is,
True.
and they come, and then this is what I want it to be.
Yeah, and I think ultimately that number was designed to create some consistency from green to green on the golf course, not necessarily a competitive thing with other properties. It's a pretty subjective thing, like you said. Light meters, that's something that I actually utilize quite a bit for shade issues. But I don't hear a lot of talk about that. Is that something that you guys, I know the greenhouse industry is utilizing that, but does that conversation come up much with golf?
So where I'm familiar with that being an issue with golf is, all right, so you have your golf course, and this is just an example, and they got this landscaping around it, right? So the superintendent is battling that shade, but I need to thin these trees, or I need to remove a tree, and the cleans committee says, no, people love those trees.
Right.
You say, all right, but here I'm only getting so much light. The grass needs so much. So, I mean, do we want to get artificial lighting? Do we want to live with maybe a little bit substandard turf because we want the trees, or no, we'll take out the trees? Another interesting part of that was there was the soccer stadium in Chicago, and they were having trouble growing grass at one of the goals because there was the big jumbotron behind it. And it was casting shadow on there all the time. I don't know how she dealt with it, but now at least she could quantify, well, these are the troubles I'm having with light. And I don't know what she did as a response to that, but at least knowing, I have light issues, or maybe changing this hybrid of grass or something that maybe is more shade tolerant. I don't know
stadiums have to be some of the most challenging things I've seen. Just like you said, you've got grandstands and jumbotrons and all kinds of things that are working against the turf manager all the time. And do you get into any kind of measuring on artificial turf?
I mean, you could measure
temperature, I suppose.
Temperature is probably, I think that's no. Another thing I'm just thinking off the top of my head of something that's used a lot more in other areas, like in apple orchards and vineyards, but is disease modeling. So we do have disease models for turf grass, and they require leaf wetness and temperature data. And we have some small, real affordable loggers that can record that. I don't know how. I mean, we have turf disease models available. I don't know how many people have purchased them. Those are real big for apple orchards, especially.
Sure.
Because you have to apply that at the right time. Because if you apply it too early, you've just wasted it, right? The fungus isn't out yet, and if you apply it too late, it's too late.
Times hundreds of acres.
But that is something maybe to think about if you're having. I want to say brown patch. Is that a turf disease?
Sure. Yeah, for sure.
That's I know that's one of the models that we have, and there's at least 2 or 3 others.
And that's something that's you're using a measurement tool and a predictive
like a weather
model.
station or a small data logger, just collecting some real site-specific data, and it can predict the onset of the disease.
So go back for a minute to the sap testing. I hear a lot about that in agriculture, and I think that's one of the things that doesn't cross over well into turf is, where you are, corn and beans are the king, right? Well, a corn plant starts out in the spring, and it's the same plant right before harvest. So to me, that makes a lot more sense to look at tissue and sap testing. But what are we measuring? Is it a full spectrum of nutrient, or is it only nitrate?
Yeah, right. So those meters, and they're made by Hariba company. They're ion specific electrodes. So there's a meter for nitrate. There's one for potassium.
Okay.
There's one for sodium. And again, that can measure fertilizer water. There are soil test kits that you can get, and then petiole sap. So you cut off some of the petiole, take a little, basically like a garlic press, and you squeeze the plant. I don't know of anybody doing that with turf. I don't know if you clipped a bunch and were able to, I don't know, it would be
It's
hard to get
it's
a
really
sap
difficult to get a
sample.
good sample, and
Mm,
is it a tissue or a sap? And it's I get that question a lot because we work with Logan Labs and get that question a lot about sap and tissue testing, and it's so variable because you're talking about a plant that's a tenth of an inch tall
mm,
and turns itself over every 3 weeks. It's really,
mm,
really difficult to put your finger on it versus an 8 foot tall corn plant that was planted
mm.
in the spring and essentially has remained the same through that whole growing period.
So I think that's why optical methods are
Yeah,
almost, that's all that's really
yeah,
used for
really
that
good
in
point.
turf. Yeah.
Okay, so let's wrap up with maybe a look into the future. What if anything are you working on as a
Hmm.
company, and what should we be excited about?
Hmm. All right. So a big thing now is telemetry, is getting the data, and I can just sit at my desk, and just see it.
Yeah.
So we have, um, so for a long time, we've had modems that could either work through the cell network or through Wi-Fi. So Wi-Fi would maybe be like in a greenhouse,
Okay.
any way you can get up to the web.
Right.
So there's a thing, it's called LoRa, LORA, and that's like long range. So this is a telecommunication platform that can travel over much larger distances. I want to say like if you have real decent line of sight, like 5 miles.
Hmm.
But you can't send a lot of data over it. But we don't need to send a lot of data, right? The cell network is made up to send phone conversations and videos and
Right.
all this kind of thing, right? But this LoRa, I think they call it like chirps or something. There's a little, toot, and then you send it, but that's all we're sending, maybe 10, 20 pieces of information. And
Okay.
then 5 minutes later, we're going to send another one. So the first application for that is a soil moisture profiler. So this is a single tube, but it has multiple soil moisture sensors in it. And you put that in the ground, and you can connect it to our weather station if you want, but we also connect it to one of these LoRa nodes. And then it goes to a gateway, and then you get it. And there are several different configurations of this. Now there's like a temperature one, and this would be people like frost alerts. So they
Okay.
want to know temperature, but their field is, kind of far away from where they
Yeah.
live. With this LoRa technology, because they only need to send it every, I don't know, 15 minutes. When does the
Right.
temperature get below whatever? And so it's a much more affordable way to get that remote
Huh.
information without having to go out there. And I know that, and then there's some, and basically it's all the communication node, and then what sensors do you want to put onto it? So
Right.
that's what the product development is working on now, different flavors of this LoRa communication platform.
So it's almost like an extended Bluetooth sort of a concept, maybe.
I I guess you have to talk to the gateway because the gateway is what sends it up to the web.
Okay.
But Bluetooth can only go like 150 feet, but this
Yeah.
can go miles
Miles.
potentially.
Interesting. Interesting. Well, that's
And
very
so,
cool. Yeah, technology and communication, I think that it's just advancing at such a rapid pace, and I'm sure at some point AI will play a role in how you develop products but I could tell you that I got exactly what I wanted out of this conversation, and
good, I'm
I
glad.
appreciate it. I don't know anybody that wouldn't be familiar with your company, but how do we get a hold of you? What's your website? If
Okay.
somebody's interested in looking at what you've got available.
So the website is www.specmeters. So the
Okay.
first four letters of spectrum, SPEC, meters, plural.com.
Okay. All right. Well,
And
Doug Kieffer, I appreciate you coming on. I told you at the beginning of this before we hit the record button that an hour would go by pretty quickly, and
it
hopefully
sure
you found that.
did.
Yeah, hopefully you found that to be the case. But this is really informational, and I appreciate you coming on. And I think your skill set is perfect for being able to, like you said, to bridge the gap between the engineer team and the field managers, and really interesting. I'll definitely keep up with you on what's coming down the pike, and look forward to seeing you at the show this coming year. And thanks so much for your time. I appreciate it.
Well, again, thank you for inviting us.
Yeah, you bet. You bet. We'll talk to you soon. And for those of you that are listening, thanks for tuning in again. And if you're not subscribed to get our weekly updates, make sure to do so. And we appreciate everybody listening.